In this video, we'll find a general solution for the system of differential equations given by x prime equals 3x minus 4y plus 1 and y prime equals 4 times x minus 7y plus 10t. Our first step in order to solve this is that we're going to rewrite this system of differential equations in terms of operator notation. So we are going to rewrite this in operator notation. And what that means is we're going to use the differential operator d for x prime. So the first differential equation becomes d of x equals 3x minus 4y plus 1. And then the second one is d of y equals 4x minus 7y plus 10t. Now we can simplify or rewrite that as follows by bringing everything with x and y on the left side. So when I subtract 3x, I can write this as d minus 3 times x, or acting on x, and then plus 4 times y equals 1. So I brought the 4y to the other side. On the left-hand side, I can bring the x and y to the other side, and I'm going to start with x to keep the same grouping as I have in the first equation. So I'm going to first subtract 4x, and then I'm going to write plus d plus 7 acting on y, and that equals 10t. Now notice that I left off the variable t in my notation, and that's just to avoid clutter. But anytime you see x and y in these equations, you have to think of x being a function of t and y being a function of t. So once we have that, our second step involves eliminating one of our unknown functions. So we're going to eliminate x or y. Now, I have a d minus 3x here and a minus 4x here. So what I can do is I can multiply my first equation by 4. So if I multiply the first equation by 4, so 4 times d minus 3 acting on x plus 4 times y equals 1. And then multiply the second one, or apply the differential operator d minus 3 on the second one. I get d minus 3, and that's acting on negative 4 times x plus d plus 7 times y, and that equals 10t. Now note that I use used 4 and not negative 4 here. And that's because I can now add these two equations because they have opposite sign. So I get negative 4d minus 3x, and here I get 4 times d minus 3 of x, and that cancels each other out when you add. So the x's cancel, and what we're left with is 4 times 4y and then the second part is plus d minus 3 acting on d plus 7 acting on y. And then on the right hand side, I should not forget that I multiply that 1 times 4. And then the second part, I add d minus 3 acting on 10t. So now let's simplify this and see what we get for y. So 4 times 4y, that's 16y. For the second part, we know that when we have linear differential operators that act on each other, we can just multiply this out. So you would FOIL this, you would get d squared plus 7d minus 3d and then minus 21, and that is acting on y. And on the right hand side, you get 4 times 1, that's 4, and then the derivative of 10t minus 3 times 10t. Okay, let's simplify this a little bit more. 16y plus d squared of y, that's y double prime. And then we have 7dy, so that's plus 7y prime minus 3y prime minus 21y. And then that equals 4 plus derivative of 10t is just 10, and then minus 30t. Okay, and now we see that we're getting a linear second order differential equation here on the left. So we start with y double prime. 7y prime minus 3y prime gives us plus 4y prime. And then 16y minus 21y, that gives us negative 5y. And on the right hand side, we get 14 minus 30t. And this is a differential equation that we've looked at in chapter 4. So what we need to do is, in order to solve this, which will be our third step here, we're going to need to solve the homogeneous equation, and then we need to find a particular solution. So third step is we're going to solve for y, or x if you solve for x in if you solved for x in the second step. So we know that our solution will look as follows. So we have y equals yh plus yp. So it's the solution to the homogeneous equation and then a particular solution. Now, to find the particular solution, we can use the method of undetermined coefficients, or you can use variation of parameters. In the interest of time, I will give you the following solution: c1 e to the power t plus c2 e to the power negative 5t. This is the homogeneous part of the solution, and then plus 6t plus 2, that's the particular part of the solution. So this part of my general solution for y is the solution to the homogeneous equation, where you set the right hand side equal to 0 and you use the auxiliary equation. And then this second part, that's the particular solution. And again, I strongly encourage to pause the video and check this for yourself. Okay, now the last step to get x, we need to plug y in, and in this case, it could also be x, right? Depending on what you solve for. So plug y or x into an original equation. Now, previously, when we looked at an algebraic problem, it doesn't really matter what you substitute this equation in for. However, there is both will work. We can substitute y into both equations, but one will be quite a bit of extra work and the other one is clearly faster. So we have two options, right? So we know what y is. So we can either substitute it in here, or we can substitute y and its derivative into the second equation. Now, if we plug it into the second equation, we first need to find y prime, but the payoff is that when you solve for x of t, that this equation, once you plug in y, only has x, and you can find x by just algebraic manipulation. However, if we plug in y into the first equation, we get another differential equation that involves x prime and x. And so we would need to solve a second differential equation if we plugged it into the second equation, plugged it into the first equation here. So really what we want to do is we want to substitute y that we just found into the second equation to save us some work. So in order to plug it in, we need to know what y prime is. So y prime here is given by c1 e to the power t minus 5c2 e to the power negative 5t plus 6. Okay, so now we're going to plug that into the differential equation over here. So the differential equation is given by y prime equals 4x minus 7y plus 10t. Let me do that in a different color to make it pop out a little bit more. So I'm going to take this and plug it into my differential equation, which is y prime equals 4x minus 7y plus 10t. Right, so I have y prime equals 4x minus 7y plus 10t. That's our original differential equation, the second one. Okay, so when I do that, I get c1 e to the power t minus 5c2 e to the power negative 5t plus 6 equals 4x minus 7 times c1 e to the power t plus c2 e to the power negative 5t plus 6t plus 2. And then plus 10t. Okay, and at this point, it's basically algebra. So we get c1 e to the power t minus 5c2 e to the power negative 5t plus 6 equals 4x minus 7c1 e to the power t plus 7c2 e to the power negative 5t plus 42t plus, sorry, this is a minus. So I have I have minuses here. So I have minus 17, 7c2 e to the power negative 5t minus 42t, and then the last one is minus 14. So minus 14 plus 10t. And I will leave it up to you to solve that for x, which just involves moving everything that's not x to the right, and then in the end dividing by 4. And check this for yourself, that you get x of t equals 2c1 e to the power t plus 1/2 c2 e to the power negative 5t plus 8t plus 2 plus 5. Sorry, last part is plus 5. And then y of t, we found that to be c1 e to the power t plus c2 e to the power negative 5t, and then plus 6t plus 2. And that is our final solution. Now, we could figure out what C1 and C2 are if we were given initial conditions for this system of differential equations, but they are not given, so a general solution is all that we can do with the given information.